There is the first case whereby the center is at the origin. Okay, so this is like case 1. Okay, that's the first case. So give me a second to calculate. So the first case is when the center is at the origin. So this is case 1. Now with case 1, it's just the use of the theorem of Pythagoras to get the equation. So we have got our center here, point P there, where the value of x is x, the value of y is the y. So if you want to find that equation, you use the distance formula. Okay? You need to calculate the distance from this point up to that point. Right? So I'm sure you are all aware that x is 0 here and y is also 0 here. So if you use your distance formula to calculate the length of OP, you end up getting OP squared equals x minus 0 plus y minus 0 all squared. Obviously the x minus 0 is squared. Then when you simplify, you get OP squared equals x squared plus y squared. But this OP is equal to r. So your equation will become x squared plus y squared equal to r squared. Now this equation, remember we can also write it as r squared equals x squared plus y squared, is called the equation of a circle with center at the origin. You have encountered this equation before in trigonometry. Okay? You've encountered in trigonometry from grade 10. So that equation, r squared equals x squared plus y squared, it's actually an equation of a circle. But the circle must have a center at the origin. Okay? So if you see a question talking about the equation of a circle of center at the origin, it will be referring to this equation. Okay? Whereby this r here, that's the radius, where r is the what? The radius of the circle. So sometimes you may need to calculate the radius if it's not given. There are times when it may be given. So generally this is the equation of a circle with a center at the origin. That's the equation of the circle with the center at the origin. All right. So let's determine the equation of each of the of each of those circles. Now remember the general equation is r squared equals x squared plus y squared. This can also be written as x squared plus y squared equal to r squared. Now for grade 12 analytical geometry, generally we write it like that. Okay, that's the format that we should follow from now on when it comes to the equation of the circle. We start with x squared plus y squared, and that will be equal to r squared. Okay, so here our center is at the origin. Okay, and we are given a point at the circumference. So if you want to determine the radius, you have to use the theorem of what? Of Pythagoras. Remember that. Okay? So all we do is to use the equation that we know from grade 10 in terms of our trig. So r squared is equal to x squared plus y squared. And our x there is minus 3. So I'm doing here question 1a. right? So it's minus 3 squared plus y squared plus 2 squared. So that will give me 9 plus 4, and you can get 13. So this is equal to r squared. What this means is that my equation therefore means that my equation is going to be x squared plus y squared. Right? Now, when you write it, you can just put equal to 13 here, because that's equal to r squared. We can also write it as x squared plus y squared equal to the square root of 13 all squared. Because here, if I solve for r here, what do I get is 9. Get square root of 13. And in the equation, the general equation, the r must be squared. So I can write it like that. Okay? I can write it like that. Alright? In this case here, I would prefer that you learn to write it this way, because this is what you are going to encounter more, that format. Right, so that's 1A. Then we can do another one. Okay, B. Now that B there, you see this square root of 11 is this point here. That means x is equal to square root of 11 there. What's the value of x at that point? It's 0. Yes, well, this point here is on the x-axis. So y is 0. I told you even a few days ago that along the x-axis y is 0. Along the y-axis x is what? Is 0. This equation here, that is the y-axis, its equation is x equal to 0. The equation of the x-axis is y equal to 0. You have to know that not only for analytical geometry, but even for your functions, and you have to know this. The x-axis is an equation, and that equation is y equal to 0. The y-axis is an equation, and that equation is x equal to 0. Okay? Make sure you know. Okay, so here, if I want to find my equation, let me move on to the next page. So I'll write I have to determine x first. Okay, x is squared equal to 11, y is 0. So if I want to calculate the radius, it will be r squared equal to x squared plus y squared. My x is square root of 11, then I square that. My y is 0. So it means my r squared is going to be the square root of 11 all squared. Now here, I'm not going to try and square that square root of 11 to find r. I'm not going to do that. So straight away I'll write my equation. It's going to be x squared plus y squared equal to the square root of 11 all squared.
So,
yes?
how is it going to be? How is it going to be?
No, this is r squared.
Yeah. But then I'm thinking in sentence over
No, remember this is the same as 11.
Yeah.
Yeah. So what's your question?
It's I'm confused with that one. You see where it says x squared, y squared. You have to put r squared the same. So you see x as a square over there. You let the square root of it. You just have the 2.
Wait, okay. No. I'm really confused with what you say. Kids, what are you saying?
So, you see, it's also called the level. So everyone has saw the questions, and now you just go straight to the final answer level. Or you're not writing it as a level, why is it not a level?
Okay, you see, the main reason why we don't write as 11 is because generally when it comes to the equation of a circle, we don't need to find the actual value of r squared, but we need to find the value of the radius r. The value of the radius r is more important than r squared.
Oh.
Okay? So, because remember our equation of a circle is x squared plus y squared equals r squared. So when I write it, my r squared, I have to write it with the square. Okay, generally that's how you, if you don't do that, you are going to find that later on, you might, if you do the more complex examples, you might need to complete the square and so on. Okay, later. So let's write it in this format. That's how I do it. Okay, so I don't want to waste too much time here. Let me move on to the one which has got a center. Okay, so let's do it. That question. Okay, just as a reminder, our equation of a circle is x squared plus y squared equal to r squared. So for this question it says, determine the equation of a circle center at the origin passing through the point where x is 5 and y is minus 1. Okay? Right? That's E. Right? Right. So do F also, but let me do E first. So someone might be asking why they can't do that. Alright. So that point there where x is 5 and y is minus 1, it will go on the second point. So we need to calculate r squared. So r squared is equal to x squared plus y squared. My x there is 5, my y is minus 1. Okay, then you get 25 here plus 1, which gives me 26. Okay? So r squared is equal to 26. But what is r? R is going to be equal to the square root of 26. So my equation is going to be x squared plus y squared.
Why are you going to find all of that?
Because when you write the equation, you write it in terms of r squared. Okay? So I found r here. In the previous example, it was the way the question was different because this was a diagram. Okay? Y is 0 here. And x is square root of 11. So it's different. Right? Here I have to determine r. Okay? Your r will be square root of 26. Are you following that?
Yeah.
My equation, I have to write it using, I must put this square in my equation. So the only way that I can have that square is by finding the square root of the radius.
Oh.
Okay? So this becomes the square root of 26 all squared. Because square root of 26 squared will give you 26, which is equal to r squared. But when you write it, you need to write it in such a way that you square the length of the radius when you're writing the equation of the set. Yes?
You don't have to do that.
No, in this case, they didn't say draw a diagram. But if you want to draw a sketch for your own reasons, in terms of understanding it, you can do that. Okay. Alright, so let's do F. Now, F, it says the radius is 2 square root of 5. Okay? Now, I hope you can understand that if the equation is x squared plus y squared equal to r squared, right? We don't know the value of x and the value of y, but the good thing is we don't need to calculate x and y. As long as the radius is given, it means things are made easier for us. All we have to do is substitute this radius here where there is r there. That's all. So the equation becomes x squared plus y squared. The center is at the origin, so the equation will always have x squared plus y squared. Right? The radius, it will be 2 square root of 5 all squared. And that will give you x squared plus y squared equal to 2 squared times the square root of 5 squared. I hope you are seeing what I did there. When you square the 2, you also square the square root of 5. So the final answer will be x squared plus y squared is equal to 4 times the square root of 5 all squared. Right? I just want you to read it like this. or you can leave it like that, but I just simplify it. Okay? It will be okay to leave it like that. Because it's in the format x squared plus y squared equal to r squared. Right, so this is the basic equation of the circle. Right, let's move on to the one where the center is not at the origin. Right? If the center is not at the origin, that's the most common case. Right? So, our center of the circle is no longer at the center. So it's no longer as well, rather at the origin. It's no longer here. It's no longer here. It's now at another point, or it's now in any quadrant. Now, so the center we represented by capital letter M, where x is equal to A and y is equal to B. Obviously, we still need a point on the circumference. Okay? So, to calculate that equation, we use our knowledge of the distance formula. So, we use the distance formula. So, in this case, that radius MP is going to be equal to MP squared is equal to x minus A squared plus y minus B all squared, whereby MP is the radius. So eventually the equation can be written as x minus A all squared plus y minus B all squared equal to r squared. This is the general way of writing the equation of a circle with the center not at the origin. That's the general way of writing it. You start with the terms in x and y on the left hand side, then the radius must be on its own on the right hand side. Okay? Now, the concept of completing the square is going to be required in some of the scenarios or situations for the equation of a circle. So that's your equation there. I'm sure you can see that from these equations, I can get the one where the center is at the origin by substituting A equal to 0 and B equal to 0. Okay? If you substitute A equal to 0 and B equal to 0, you get the equation of a circle with center not at the, sorry, with the equation of a circle with the center at the origin. Okay, so let's use this equation. It's